Let's solve lead code 2441, largest positive integer that exists with its negative. Given an integer array nums that does not contain any zeros, find the largest positive integer k such that minus k also exists in the array. Return the positive integer k. If there is no such integer, return minus 1. So let's look at this example where you can see that 3 and minus 3 exists, so you will return 3. In this example, both 1 and minus 1 and 7 and minus 7 exist. Because 7 is bigger, we return 7 as the solution. And in this example, no number with its negative exists, so we return minus 1. Again, this problem has three solutions: the brute force n square solution, the sort n log n solution based on sorting, and order n solution that uses extra space. So let's start with the brute force solution. So let me say n is equal to integer n is equal to nums.size, and I'm going to make answer to be minus 1. I'm going to do the following. As I walk over this array, let's go here. As I walk over this array, I'm going to take 6, and I'm going to see if there's a minus 6 on the front of the array. Or in this case, if 7, if there's a minus 7 in here, or minus 7 if there's a minus 7, which is 7 in the front of the array. And if there is, then I'm going to take the maximum of the value. So let me do I going from 1 up to n, I plus plus, and I'm going to search this nums I in the front of the array, meaning j going from 0 to I, not including I, of course, j plus plus. And the question is, if nums j is equal to minus of nums I, then we found it. So I'm just going to say answer is equal to std maximum answer nums. Actually, I don't know which one is the positive, so let me take the absolute value. So std abs nums I. So let me take the absolute value of it and then break out of this inner while loop, and here just return the answer. The reason I had to take the absolute value was because I don't really know whether nums j is the negative value or nums I is the negative value. Like in here, when I go to minus 7, which is nums I would find 7 in the front of the array, but I am taking nums I, so I don't know if it is, which one is the big, the negative number. That's why I have to take the absolute value. So let me run this thing, and you're going to see this is a n square algorithm. And let me submit. Yes, it works, but it is slow because it's an n square algorithm. What we are doing is for I is equal to 1, this iterates 1 time. When I is equal to 2, this iterates 2 times. In the worst case, of course. When I is equal to n, this iterates n minus 1 times. It's 1 plus 2 plus 3 up until n minus 1. That's nth order of n squared. So, but it doesn't use extra space. So this is order n square algorithm that uses order 1 extra space. So how do we make this a n log n algorithm? What if we sort the array again? So std sort nums begin nums n. So what do we see? So let's go to the problem description and think about it. So let's take this array as an example. What happens if we sort it? So what we are going to get is minus 7, right? So we're going to get minus 7, minus 1, and then 1, 6, 7, and then 10. All right, so after sorting this input array, it's going to get converted into this. So now I'm going to apply the two-pointer approach. I'm going to have a pointer pointing to the left-hand side, another pointer pointing to the right-hand side, and I'm just going to add them up as I walk. So 10 plus minus 7, that's 3. So that's as soon as it's equal to 0, I found it, right? So 10 minus 7, that's 3. That means this number is bigger, so I'm going to decrease this index. Now it's a 7 minus 7 plus minus 7, that's 0. So I found it. I'm going to return. So it's again sort and process algorithm. So we already sorted it. This is again n log n. And now I'm doing the two-pointer approach. So let's do int for integer left is equal to 0, right is equal to n minus 1. So I don't need this answer anymore, right? So right is equal to 0 and left is less than right for as long as left is less than right. So let me do sum is equal to nums left plus nums right. And if sum is equal to 0, then we return nums right because that's the positive number. I know it this time because we sorted it, right? So if the sum is equal to 0, it's like adding minus 7 to 7, then we can immediately return nums right. Otherwise, if sum is less than 0, that means the number on the left hand side is smaller, is bigger in the sense of absolute value. So I need to increment the left pointer. Otherwise, I need to decrement the right pointer. All right, if I come here, that means I couldn't find it. So I'm going to return minus 1. So let's run this thing. It's a two-pointer approach problem, as you can see. We're just moving these pointers. Either we are moving left or we are moving right. So at each iteration, we are reducing the size of the array to be processed by 1. And as you can see, this is quite a fast algorithm. But this is still an n log n algorithm because we are doing sorting. So this is again sort process type of an algorithm. So let's think about now how we can make this a order n algorithm if we use extra space, order n extra space. Again, the idea is to, I'm going to again use a answer which is equal to minus 1, and that's what I'm going to return at the end. The idea is again the same. So this is a searching problem. So as I walk over this array, I'm going to insert the numbers that I've seen into a hash set, and at any time I'm going to ask if the negative value of the number that I'm considering at this point already exists in the hash set. If it does, then I've found it, so I'm just gonna use it as one of the solutions. So declare a hash set in C++, that's on unordered set, and we're going to store integers. Let me call it my set. So let me walk over the numbers one at a time. So it's nums. The question is, if my set dot find, does it contain find nums minus number? So if it contains the minus value of this number, then I found it. So it is just one of the solutions, of course. So answer is equal to std max again, answer. And again, I have to take the absolute value because I don't really know if the number is positive or negative. So that's one of the answers. And I need to insert this value, my set dot insert into the set. Right, so I don't really need these curly braces. And that's it. That's my solution. Again, because I'm inserting the values into a hash set, we're using order n extra amount of space. This is an ordered set. But now we're reducing the running time of the code into expected order 1. Oh, I should have said is not equal to my set dot end. There are two ways to check whether the set contains a number in C++. This is one way. So let me run it, and then I'm going to show you the other way. So let this thing run. As you can see, this is correct. The other way to check whether the set contains a number is just to count the number of times that it occurs. So if it is not equal to 0, so this count is just going to count the number of times that this num exists in the. We have to count minus num. Minus num exists in the set. If it is not 0, that means there is already minus num in there, and then I found the solution. So I can take the solution. This is expected order 1, of course. This is not perfect order n because we're using a hash set, and a hash set insertion and search in a hash set takes expected order 1 amount of time. So again, this is we just have one loop that to iterate over the numbers of the given vector. This is a search. Searching in a hash set takes expected order 1, and insert into a hash set also takes order 1. That's why this is an order n algorithm, but that uses extra space, order n extra space to solve the same problem. So again, we are seeing this pattern of 3 solutions: the brute force n square solution, a solution that's based on sorting, that's n log n, and a solution that's either based on a lookup table or a hash set, which is what we're using in this case, that takes that runs in order n but uses order n extra space. Again, any questions, write them in the comments section.